Welcome to qnawire.
Okay, we have a Newman projection. CHCH3, 2H, BR, and on this back circle, we have an H, CH2, CH3, and BR. Okay, well, recall how Newman projections work. The point where all the lines meet in the middle is a carbon, which I will color in as green, and the circle in the back is another carbon. And those two carbons are bound together. We cannot see the bond because we're looking down that bond. However, if we pretend that we are looking at this from the side, say this is our eyeball, then we get a pretty good idea of what this molecule would look like. We're going to have a green carbon to our left, right? We're saying like this is our left hand and this is our right hand. We're going to have a green carbon to our left and a blue carbon to our right. And we know what's on each of these carbons, right? Because that's the substituents that are coming from this green dot. And what I see is that coming towards us is a hydrogen, going away from us is a bromine, and going up is a CH with two CH3s on it, right? So CH, CH3, CH3. Coming towards us is a hydrogen, and going away from us is a bromine. Bond between the green and blue carbons. And on the blue carbons, you see going straight down is a CH2, CH3. That's an ethyl group. Coming towards us is a hydrogen. And going away from us is a bromine. Okay, and so now we can name this molecule. First thing that I notice is that the longest chain is 1, 2, 3, 4, 5, 6 carbons long. Okay, and there are two ways we could number this. We could number this as 3, this as 4, and this as 5. Or we could number this as 2, this as 3, and this as 5. The lowest possible numbering scheme is when we put that methyl at the 2. So the blue numbering scheme is what we're going to use. 1, 2, 3, 4, 5, 6, 7 carbon chain. 7 carbon chain means that this is going to be a heptane. That's our root name. And now we simply need to name our substituents. I notice that we have a methyl on 2, so that's 2-methyl. We have a bromo on 3 as well as 5, so that's 3, 5 dibromo. And we have some stereo configuration to figure out. For example, on carbon 4 and carbon 5. So let's clear off these markings so we can figure out the stereo configuration. So let's label the priority of the substituents on carbon 3 and then figure out the stereochemistry. So the lowest priority is going to be this hydrogen. The highest priority will be the bromine. Second highest priority is the carbon attached to bromine. And the third highest priority is the carbon attached only to other carbons and hydrogens. And if we connect 1 to 2 to 3, we see that that is counterclockwise. But note that the lowest priority substituent is not in the back, which means the rule is counterclockwise corresponds to R. If the lowest priority substituent was in the back, counterclockwise corresponds to S. But since it's not in the back, we get R. So this stereocenter at carbon 3 is R. So we have a 3R. And what's going on at carbon 5? Let's assign priority. Again, hydrogen is the lowest, bromine is the highest. A carbon that's attached to bromine is going to be higher than a carbon that is not, meaning this will be the second highest priority and this will be the third. Connect 1 to 2 to 3, and we have got counterclockwise again. And we'll note again the lowest priority substituent is not in the back. Therefore, counterclockwise corresponds to R. And so we get 3R, 5R. Now, all together. This becomes 3R, 5R. In terms of alphabetizing, we can put bromo in front of methyl. We go with the B, not the D, by the way. These prefixes don't count for alphabetization. 3R, 5R, 3, 5 dash dibromo, dash 2 methyl, dash 2 dash methyl,